But first up, right after this quick break, there's some incredible new research being done at Montana State University. I think they got a grant from NASA, and they're going to use radiation from space to help with cyber security. Sounds like really interesting stuff. We've got one of the lead researchers on the phone lines from MSU with us coming up right after this.
Broadcasting live across the great state of Montana, this is Montana Talks with Aaron Flint.
Like turning lemons into lemonade, a Montana State University research team hopes to turn the radiation of outer space into a cybersecurity tool that could protect sensitive data transmitted by satellites. That's just some of the work that's being done at Montana State University. Joining us now here on Montana Talks, of course we're on in Bozeman on 1450 KMMS, we've got Brock Lemires, a professor at MSU's Department of Electrical and Computer Engineering. He's leading this project and another right now as well. Brock, great to have you on the show. Thanks for being with us this morning.
Good morning.
So how does this all work? How are you using radiation to protect sensitive data, like as a cybersecurity tool?
Yeah, so when you communicate information, you've probably heard that computers use ones and zeros to transmit it. Well, one of the things that happens is as you transmit those ones and zeros, hackers or other people who want to listen into your or get access to your information can figure out what you're sending by tracking that information. So one of the things that we do to make information links secure is we encrypt the information. So you can almost think of it as using a secret decoder ring to scramble the information before you send it, and then when you receive it, the person that receives it also has the descrambling key, and they can figure out what you meant to send. So when you do that, the person that's listening in has no idea what the information is. So one of the keys to this is that you have to use random numbers to generate these scrambling keys. And one of the things that happens in regular computers is that we don't use true random numbers. So even though we scramble the information, a hacker that's listening can actually figure out what your key was if it's not a truly random key. So what we figured out is that when you put computers in space, they get bombarded by radiation, and the radiation causes those ones and zeros that are in a computer to actually flip. And the flipping between ones and zeros is truly random. So we had this idea of what if we could use that radiation and its effect on computers in space to create the truly random numbers that are used in data encryption.
Interesting. So would you have some sort of like a radiation device that would, or would there be like I know these are very stupid questions. That's why I'm on the radio and didn't go through electrical engineering or something at MSU. But, having used encrypted devices and information, overseas and things like that through the military, I guess, how does this work? How do you use it? Would there be a device, or would there be some sort of a coding around the wires? I guess give us the basics.
Yeah, so what's neat about this idea is that you don't need anything. You don't need any sensors. You don't need any external device, because the computer chip itself is getting hit with the radiation. And the radiation that's causing these bit flips, it's high enough energy that it passes through everything. So it'll actually go through, the outside of the computer. It'll go right through the computer chip. And so what happens is that the computer is just having these bit flips inside just on its own when it's in space. And so what we've been doing for, over a decade is trying to figure out how to build computers that can continue operation when they're getting bombarded by this radiation and having these bits flip. And we discovered recently that, okay, we've built this computer that can continue operation in the presence of the radiation. What if we then use that radiation and its truly random nature to actually create these random encryption keys to secure our data? So the beauty of it is that you don't actually need anything else beyond the computer chip.
Wow. So all contained, that's pretty incredible. That would also seem to me this research that you're doing would have other secondary effects, because when we hear concerns about things like solar flares that could wipe out our electrical grid, it's happened in past history, for example, that if you're able to protect computers or computerized devices from things like radiation, would it also protect from things like solar flares potentially? I mean, that could be pretty dramatic also.
Yeah, absolutely. So the project that we've been working on for over a decade to try to create computers that can operate in the presence of radiation could absolutely be used for that. Now, that only keeps your computer chip operational, but in many situations where there's, kind of a catastrophic event, computers are used to try to mitigate the impact of that.
And how do you do all of this testing? We got only a couple of minutes left. I know we just got you for a few minutes. We'll have to have you on for a full hour one of these days to talk more about your research. But so how do you do all of this research from Bozeman, Montana?
So what we do is you can't test it on Earth, because when this radiation hits the atmosphere, its energy is dissipated. So you have to get outside of the atmosphere. So this most recent grant, we are going to be flying on a high-altitude balloon, and that will take us up to over 100,000 feet, and that's where you are out of most of the atmosphere and you're in the blackness of space, and we're able to get bombarded by this radiation. So the key approach that we've been using at Montana State is that to truly test these ideas, we have to get in outer space or close to it.
Very interesting. Well, hey, can you attach a GoPro camera or something even better to it so we can see the video footage as you do some of this? Or?
Yeah, absolutely. The platform we're going to be using is from a company called Worldview in Texas, and they absolutely have a live stream of it, and we'll have a bunch of pictures of the mission that's going to take place late 2019.
Wow, yeah, fascinating work being done there. Brock Lemire's from MSU and the College of Engineering and working on all sorts of fascinating research. That's why I've always joked, I may be a Grizz fan, but I've always been a fan of MSU academics, even though I'm a UM alumni. So I really appreciate you joining us this morning, Brock. Great to have you.
All right, thank you.
All right. Hey, if you want to find out more about that program, by the way, check out the full story at montanatalks.com. Quick break. Phones are open for you. 294-0970.